All right, so now that we've talked about the different states of matter or phases of matter, let's talk about properties of matter. And before we get started talking about some specific properties, let's define what a property is. A property is basically a trait or characteristic that helps us to identify something. So all of these different things that we will be discussing are pieces of information that we can actually use to identify a particular piece of matter. So the first set of properties we are going to look at are the physical ones. So we're going to talk about physical properties as well as physical changes. All right, so what exactly is a physical property? A physical property is a physical characteristic of a substance. In other words, it is a characteristic that can be observed without changing how the matter is composed. So for instance, if I look at something or use my senses, I'm actually making observations on the physical properties of something. If I look at a piece of clothing, for example, and note the color, that is a physical property of that piece of clothing. I don't change the chemical makeup of that clothing just by making note of that physical property. Examples include things like I said, color, density, hardness, shape, texture, melting point, and freezing point. So what we're going to do is we're going to spend our time going through quite a few here of physical properties and talking a little bit about them. A lot of these are your vocabulary words for this unit. The first one we're going to look at is viscosity. Viscosity is the resistance to flow by a liquid. We usually talk about viscosity in terms of a comparison. For example, comparing honey to water. And this is typically done simply because we don't have the instruments here at the high school to actually measure viscosity. So if I take equal containers of honey and water and we pour them out at the same time, which will empty first? Well, the one that will empty first is the water, and that is because, in other words, why? Water has a lower viscosity. So the easier something pours, the lower the viscosity. The harder it is to pour something, the higher the viscosity. And this is actually what we compared in the measurement lab back in Unit 2, where we had the corn syrup tube with the ball inside of it, and the ball fell through the liquid, and we took the time. We were actually practicing taking time, timing things. So we were actually looking at the viscosity of both the corn syrup and the polyvinyl alcohol. What we should have noticed in that lab was that the viscosity of the liquids decreased as the liquids were heated. And we see that even in the honey example. The warmer the honey is, the easier it pours. Okay, the second physical property is conductivity. Now, conductivity is basically the ability to move heat and electricity. This is one of the few physical properties we can actually observe without changing the shape of something. Okay, matter that is able to conduct is called a conductor, and it's usually a metal. A good way to think about this is which would make a better grilled cheese sandwich, a metal skillet or a wooden one? Well, obviously the metal one does because it is a better conductor. Wood does conduct heat, but not as well. It would take a really long time to make a good grilled cheese sandwich using a wooden skillet. The third physical property we're going to look at is malleability. Malleability is the ability for a solid to change shape through hammering. So the idea here is that you hit the object and it changes its shape and it actually stays that way. It doesn't break apart. You can actually hit something to create a new shape, or you can thin something. So in other words, take it down so it's very, very thin. Again, this is usually a metal. One of the examples that you may have seen is in some of the better stores. They actually have bowls, metal bowls that have been hand hammered. And so they start with a sheet of metal and they actually hit it around to make that bowl shape. And that's actually, some of the more expensive bowls are actually made this way. Now, not everything is malleable, and we do have a word that means the opposite of malleable, and that is brittle. When we hit an object and it actually shatters when it's hammered, that is what we refer to as brittle. So, for instance, glass is brittle. It is not malleable. The fourth one is ductile. And this means that matter is able to get pulled thin into wires. Basically, it means you take that piece of matter, you hold it on either side, and you pull it almost like pulling taffy. Again, these are usually going to be metals, because in order to get them that thin, you need to be able to hold together. The next physical property is hardness. And this is the ability of a substance to resist scratching, bending, scraping, or cutting. What we do is we compare hardness, again, very much like viscosity, by taking two different materials and seeing which one scratches the other one. We actually do have the hardness scale, and the hardest natural material that we have in the world is a diamond. All right, sorry about that. Somebody walked into my room. Oh. All right, let's try that again. All right, the next physical property we want to look at are melting and boiling points. Melting and boiling points are actually dependent upon both temperature and pressure. So these can slightly adjust, but in general, we talk about these as constants within a substance. Melting point is defined at the temperature at which a solid turns into a liquid, and the boiling point is the temperature at which a liquid turns into a gas. Every substance on Earth has a unique combination of these melting and boiling points. We use melting and boiling points to test a purity of the substance. So in other words, does it have something else in there? Because if there's something else mixed in, it will actually change the melting and boiling points of that substance. For instance, salt water actually boils at a different temperature than plain water. It also can be used to help identify something that we don't know what it is, because we can actually melt it and then take a look at what those temperatures are and compare it to a list of things that we know. So this is actually a table of melting and boiling points of some various substances. The one that you need to pay attention to here is the water. Okay, right here. You need to know that water melts at 0 degrees Celsius, which might be different than what you know. You know that water freezes, but actually their freezing point and their melting points are the same. In addition, water boils at 100 degrees Celsius. Again, of everything on this table, that is the only one that you need to know. So now that we've gone through a bunch of different physical properties, how are these useful? So why are we looking at them? These can actually be used for us to solve crimes. You look at physical properties of the evidence that's collected, and you can actually match up the evidence then with the suspects who were present and probably committed that crime. We also use it to prevent cheating in sports. For instance, auto racing, you can look at the fuel. We also use the physical properties of things like blood and urine to see if athletes are actually using different drugs or performance-enhancing techniques in order to get ahead of their competition. So when we use physical properties to actually identify something that we don't know, we have to be a little strategic. First thing we need to do is we need to select the properties that would be most helpful that we would want to test. So for instance, if I have something that isn't a metal or doesn't look like a metal, it may not be useful to test if it's ductile or not. But we don't know. Everything is very situational specific. So then once you've decided on those tests, you perform those tests on the sample, and you compare the results to those of known substances to determine what the identity of that substance is. So those are physical properties. Now let's take a look at physical changes. Physical changes are when we change the properties of the material. We change the physical properties, but the chemical identity actually stays the same. So this includes things like boiling, melting, slicing, breaking, and cutting. If I boil something, I can condense it back down. If I melt something, I can refreeze it. So in a lot of cases, physical changes are changes that we can undo. Now, something like slicing or cutting, I can't always necessarily undo, but I haven't changed. Like if I cut a piece of paper, I haven't changed the fact that I have paper. I just now have two pieces of it. So if I look at the molecular or the atomic or the particle level, the particles are going to move farther apart or closer together, but they don't separate. So I don't take water and separate it into hydrogen and oxygen, for instance, when I boil it. It stays together as water. So now let's go over to the other type of property and change, which are chemical properties and chemical changes. A chemical property is the tendency of a substance to change its chemical identity. So in other words, it actually changes the makeup of it. An example of this would be iron changing its identity to rust when combined with water and oxygen. The iron is still there, but it's no longer just plain iron. It's actually combined with other things. So we're going to look at two chemical properties, the first of which is flammability. This is the ability of something to burn in the presence of oxygen. And if you think about it, when I'm testing for chemical properties, I'm actually destroying the substance, because if something is flammable, there's no way that I'm going to not change it. When I burn something, it's not coming back. The other chemical property is reactivity, and this is used to describe how easily a substance changes chemically when exposed to another substance. We have some substances that change chemically very easily, and we have some that very rarely change their chemical identity. And this actually helps us to figure out what we're working with. Now, chemical properties are actually very closely related to chemical changes, because oftentimes when we're testing for chemical properties, if those chemical properties exist, it results in a chemical change. This occurs during a chemical reaction. And what happens during a chemical change is the substance changes its identity. So for example, if I test the flammability of something like wood, wood will burn. It is flammable. And so in testing that, I get the atoms actually rearranging themselves to form carbon dioxide and water vapor. Contrasting with a physical change, I can't get them back. I can't just take carbon dioxide and water vapor and magically have it turn back into wood. It's not going to happen. Another example is grape juice fermenting. When I put grape juice with yeast, the atoms are going to rearrange to form ethyl alcohol, and this is one of the processes that are involved when we make wine. Again, I can't take that ethyl alcohol and magically have it turn back into grape juice. If I look at the molecular or atomic level, the particles are actually breaking apart and recombining to form new arrangements. Now, those are the definitions, but part of what you're going to need to have to do is distinguish between physical changes and chemical changes, not just understanding what physical and chemical properties are and being able to identify those and define those, but you also need to distinguish them. So, deciding sometimes what change is happening can be a little bit difficult, but here are some rules of thumb to help you. Chemical changes often result in a release of energy. A lot of times that's heat. It could also be light. If you think of a flame with flammability or with burning, you've got both examples right there. A flame generates light, and there's also heat that is given off. Physical changes, as I've been saying, are more easily reversed. Now, like I also have said, that's not 100%, but that's also a good way to think of it. Now, the type of change that tends to get people mixed up is phase changes. All phase changes, so going from a solid to a liquid or a liquid to a gas or in any direction thereof, those are all physical changes. And those are the ones that get most confused. Students tend to think of those as chemical changes, and they're not. So in the next couple of lessons, what we're going to be looking at is the concept of density and also talking about some of those phase changes that we just discussed.